So we hear the phrase the Big Bang, but how do we know there was a Big Bang? Well, originally the Big Bang was actually a pejorative term coined by Fred Hoyle, who believed in the idea of a steady state universe, a universe that's always been here, and he mocks the idea that the universe had a beginning and sort of an explosion. Now, it's a misnomer to say Big Bang really, because it wasn't an explosion, it was an expansion. So the universe expanded from a very, very hot, dense state called a quantum singularity, and is still expanding today. And how do we know? In whichever direction we point our telescopes and look, we see that everything is moving away from everything else. And not only that, we can see that the actual expansion of the universe is speeding up. And the reason we know that is because of Hubble. Edwin Hubble was an observer and an astronomer who coined the phrase the Hubble constant, because the Hubble constant shows that, for example, if you have a galaxy that's moving away from you at, say, 5 light years away, and then you go 50 light years away, 10 times further, the galaxy that's 10 times further away is moving 10 times faster, which means that the expansion of the universe is accelerating. And this holds like a scatter graph perfectly. The correlation is almost perfect. Well, how do we know it's moving away? I know you're going to ask. Well, the way we can answer that is by studying what happens when you observe a fire engine or a police car or an ambulance, because you've all noticed something called the Doppler effect. You may or may not have heard of it or know what it means. But what the Doppler effect shows is that when you hear that sound of anything that's producing a siren noise, and it passes you, you'll notice the pitch of the sound drops, and that's because sound travels as a wave. So when it's moving towards you, the wave is slightly compressed because it will emit a wave, and the wave will go to its crest, the top of a wave, and as it goes down to the trough, the bottom of the wave, because it's moving towards you, it's actually travelled a little bit, so it squashes the wave. The shorter the wavelength, that's the distance between the crests of the wave, the higher the pitch of the sound. Now, what's that got to do with light? Well, light also travels as a wave, but we obviously can't hear it, we see it. And what we observe is that when something is moving towards us, the light is a slightly different colour when you split it into the spectrum, and it's blue shifted. In other words, there's more blue in the light than there is from a stationary object. Whereas if it's moving away, it's red shifted. And the red shift shows us that the further away something is, the greater it's red shifted, and it's proportionate to its distance, and it's a correlation. So that's how we know. We know that everything is moving away from everything else. For the same reason, we can tell when a fire engine passes us, because the pitch drops. In this case, the pitch doesn't drop, the colour changes, and that's how we know. So the Big Bang is in fact a thing.